Right. If everybody's ready, we'll start the official presentation. Welcome all at the Shopware United event. It's going to be an event filled with performance-related talks. But before we go into that, I'll do a quick intro. So please bear with me for another few minutes. After me rattling off some news, some information, and what have you, we'll actually start with the first talk, which is done by Benjamin Eberlei from Tideways and Paul Oltmanns from Radonline.de. What we learned about Shopware 6 performance from data. Afterwards, we will continue with Thomas Lohner from ScaleCommerce, who will be talking about the performance project, Declutter and optimize your frontend for fast shopping experience with Shopware 6. I told you, Thomas, it's a very long title. And we'll finish with a slightly shorter title, Shopware 6 is your ideal core web vitals boilerplate, by Erwin Hofman, who is an expert in that field. So pretty exciting stuff, and afterwards we'll have some time to chat to one another here on Zoom. Right, Shopware United. What are we? Who are we? Depending on how you got to this event, you might already have heard from us. You might have not. Shopware United is our effort to give the English-speaking Shopware community a platform online, a platform in events. We are available via Twitter and what have you. So these are some of our goals. We are doing outreach. We're making sure there is English-speaking content. We are in general making sure that we make Shopware community a welcoming place. I think a noble goal, if I say so myself. We also have events. Which is, I think, one of the most exciting parts. The next event that is going to be online is getting started with Shopware as an agency. So it's interesting for agencies that just started with Shopware. Might as well be interesting for agencies that have been doing Shopware for a longer time, as we'll dive into how to train people in Shopware and what have you. It's a virtual event, as said. Watch our newsletter, watch Twitter to get an update on that. You can also already subscribe via Eventbrite. Then we'll have the Shopware Community Day, which is an online event, and I think there would also be an offline component, but don't pin me on that. It'll be in September. The date is yet to be announced. Then we'll have a Polish Meetup, which is an in-person event in the lovely city of Krakow. If you've never been there, I can highly recommend it. It's beautiful. It's on the 27th of September. And then we have in October UK Meetup in London. Again, beautiful city. It's also in person. So I can highly recommend to book some tickets and fly over. There will be some drinks, there will be some talks, there will be some friends there from the community. So do meet us there. All right. So beyond events, how can you help us? Because this is all about community, and we're not going to do it alone. We need you. There are a couple of ways you can help us. You can join work groups. Work groups create content. Work groups help us translate certain things from English into local languages and what have you. You can organize events locally. And for that, we are here to help you. We can help you with technology like a Zoom account or a Hopin account. We can help you in presenting it. We can help you with content. We can help you with speakers. So if you want to organize a local event, do reach out to us via our website. We are looking for people to rally the local communities. That can be in a country, that can be in a city, that can be in a small village that happens to have a shit ton of Shopware developers. You never know. I mean, let's be honest, Shoppingen is a small village and there's a ton of software developers. So, right. So if you are looking to rally your local communities, again, we can help you with that. And the last, share knowledge and code. If you have something to share, we are here to give you a platform. And then final, I do want to bring to your attention a call out that we're doing for questions and answers for a special solution specialist exam that we are designing in collaboration with Shopware. As you know, there is already a certification for developers. We are looking to bring a slightly more non-technical exam that is interesting for project managers, solutions architects, and so on. And we're looking for good questions. So you can submit those questions. You can go to the shopwareunited.com site, and under news, you will find an article about that, or click on the link in the slides, which we will be posting later on. And if you submit 5 questions, you will be eligible for a free exam entry. So the price has not been set for the exam yet, but you know it should save you some money. So that's always interesting. Like I said, we are here to help you, but we also need your help. So if you want to get involved, or if you have a question, do reach out to us. We are literally everywhere. We are on the email, on the web, on the Twitter, again on the email, on Slack, in the Shopware community Slack. You can find us in various channels. So do get in touch with us. As promised, I would try and keep it as short as possible. So with that, I am more than done. And I'm going to hand you over to Benjamin Eberlei and Paul Oltmanns, who will be talking about what they learned from data and Shopware 6. Benjamin, Paul, are you ready?
Yes, hi. Thank you for the introduction, Sander.
I'm going to share my screen, and then we're trying to do a joint presentation where only one person can forward the slides.
Perfect.
Okay. Yeah, thank you very much. Yeah, Paul.
Genau. Well, I will start. Thank you all for joining us, and welcome to the presentation that Benjamin and I are giving today. We would like to talk about Shopware 6 performance and how we identified Shopware 6 performance problems with Tideways. Yes. What's our agenda today? First, I'd like to talk about my company and introduce myself, and then talk about the experience we've had with Shopware 6 and the migration to it. And then Benjamin goes into detail and talks about how he was able to identify the bottlenecks with Tideways in our case. I'll start with the introduction. I'm Paul and 19 years old, and have been working for over 2 years now in the family business of Radonline.de, and my responsibilities are in the IT and marketing area. And in the last few months, I've been working intensively with Shopware 6. Can you go back? Yeah.
Oh, sorry.
Radonline.de is an online retailer for bicycles and accessoires, and it used Magento 1 since 2010 when it was launched. And we also have a retail store in Germany. Yes. Now the next. Thank you. What led to this presentation that Benjamin and I are giving today? As I said, Radonline.de used Magento 1. And in 2020, Radonline.de and many other Magento 1 stores had the problem that the support for Magento 1 expired. So we had to make a decision. Do we continue to rely on Magento 1, or do we switch? And if we switch to a new system, which one? The decision was then made for Shopware 6. And yeah, because it's rather simple and it's based on modern technology, and we also like the RP first approach. Yeah. How did the migration proceed? In 2020, I was involved in web development anyway, and was learning PHP at the moment. So I was given the task of migration. And to migrate this shop quickly, I started to design the theme for the front end, which was quite easy because it was well documented by Shopware. And I also installed the necessary plugins for payment, like PayPal or Amazon Pay, an SEO plugin, and the tracking plugin for Google Analytics for the enhanced e-commerce tracking. Yes, and of course, we also had to connect the Shopware 6 to our other system, like the ERP system we are using and the PIM system. But these interfaces already existed or were newly developed. And in summary, I can say that the migration to Shopware was very uncomplicated. So what is the situation we're at the moment with Radonline and Shopware 6? Well, we were able to migrate successfully at the beginning of the year. Since then, the conversion rate has more than doubled due to the migration. And in addition, we have a more modern shop, which is easy to develop. And we were able to reduce development costs. But on the other hand, there are some problems. For example, the importing via API. The imports were very slow. For example, it took 22 seconds to update only the stock of one product. And you can imagine what it's like when you have to update 15,000 products. Yeah. And in addition, the product export from Shopware sometimes did not work, which is very bad for like Google Shopping campaigns. For example, if you run a Google Shopping campaign with old data and promote products that are already out of stock, you're losing money. And often this export took more than 10 minutes for only a few fields to export. And sometimes the whole export just failed. Yeah. And we also didn't like the performance on the front end. The time to first byte was too high in our opinion. It was more near 1 second than below 500 milliseconds. Yes, the next thing. Well, what did we do to identify the problems? We realized quite quickly that we could not solve the problems on our own. So we approached Benjamin Eberlei and Fabian Blechschmidt. And with the help of Tideways, we were able to identify the causes of the problems. And we have already solved some of them. And I'll now hand over to Benjamin, who will go into more detail.
Thank you, Paul. So I'm Benjamin, and I'm the founder of Tideways, and we do performance monitoring and profiling for PHP applications and also for Shopware. So when Fabian and Paul approached me with the Radonline shop, so the problems that Paul mentioned sounded like something that a few of our customers also had before. So what is sort of the approach that we recommend, or what we use or tell our customers to do, is that to find out more about your performance and sort of set up a cycle of optimizing the performance, we recommend to use monitoring for different kinds of pages, page types and tasks. Like pages are like product detail pages, category page, all the different page types that you can identify. And then also tasks like product export or import, what Paul mentioned, like the connection between the ERP system and the shop system, in a way where you can monitor the overall performance of the system. So you can say, let's say, like Paul said, it takes about 22 seconds to import a product, or it takes 10 minutes to export the products to Google Shopping. And armed with this data, you're sort of able to identify what operations have the highest impact performance-wise on your users or on your system. And also with monitoring in place, you can assess when the footprint of the different pages change. So Shop systems are always in flux. There's always a new plugin version, a new shopware version, or a third-party service that is getting slower or faster. So it's always good to have this monitoring in place to sort of get a feeling of the pulse of the performance. When you're at that place, that you have this kind of monitoring data, then you can go into the data in much more detail using a profiler. And that means you collect the performance of individual functions, database queries, and everything that is happening for specific page types, for example. Then you can go analyze them. If you found a problem, you can try to fix them. In case of shop systems, fixing the performance problem often means that you have to notify a plugin author, or you have to communicate with the Shopware core team about specific things that can be optimized in these parts of the application. Because for a Shopware shop, often a lot of the code that is executed is not actually written by yourself, but it's already provided to you by external parties like Shopware, like a plugin author. So you sort of start this cycle of communicating with them or suggesting fixes to them to improve the performance. And this is what we did here with together with Radonline. And then you sort of repeat this cycle to get better and better. So what did we find for this specific case? So first, I want to talk about Shopware performance in general, sort of give you a baseline that you can get some rough numbers about what we see in our customers and their Shopware performance. And then I'll be going into 3 stories specific to the Radonline shop, what we optimized, covering all the 3 points that Paul mentioned: the product import, the product export, and the time to first byte of the shop. So first, I want to talk about Shopware performance in general. So Shopware essentially is a shop system that is pluggable, so you can install a lot of plugins, themes, and everything like this. What does this mean is that whenever you install something new into the system, it has the potential to impact the performance negatively. And what we looked at is all the customers that are using Shopware 6. We looked at them individually, which customer sort of has the quickest category page using the 95 percentile. 95 percentile means the performance, only 5% of requests are slower than this, and 95% of requests are faster than this number. So the customer that had the lowest 95 percentile using Shopware 6 in the last 7 days had a category page that responded in 650 milliseconds. And then the customer with the highest 95 percentile had a response time around 5 seconds, 900 milliseconds. So you can see there's almost a 10 times difference in the performance. And so this depends a lot on a lot of factors. So the customer could have a lot more products. The customer could have a lot more plugins installed. They could have bad hardware. But there are many reasons, obviously, but you can see there's like a very wide range in the performance that is possible using a system like Shopware. So it's important to optimize and look at what is actually causing the performance to drop. And like Paul said, you will want to target a performance around 500 milliseconds. That is often not possible. It should at least be under 1 second. For product, we also see a performance for the fastest around 700 and the highest around 2 seconds. One question we often get is, okay, we don't care about the performance of those pages. We just enable the HTTP cache in front. And if we do that, then we can see the performance in Shopware to drop to 50 milliseconds for pages that are cached. So it can be quite fast. However, the HTTP cache you need to know what is the cache hit ratio. So how many pages are actually cached. And in many shops, this number of the pages that are cached versus uncached is very low. So it can start at as low as 10%, it goes up to 30%. And for a lot of shops that are better, it's around 70%. So what does it mean? Like 1 in 3 pages of a single user is uncached. And if the performance for this request is very slow in the ranges of, for example, 5 to 10 seconds, then this user will have a very bad experience. So it's important to also have a good performance for the uncached pages. So when we looked at the Radonline shop, this is a Shopware 6.3 shop. It's still running on Shopware 6.3. We identified a few problems using the Tideways Profiler that pointed towards the Shopware core being slow. And one of the functionalities in Shopware that is slower in version 6.3 and lower is the internal caching API. However, this was optimized in version 6.4, which was released a few weeks ago, and is now much, much faster. So we found this performance problem, and we saw that it was already fixed in Shopware. And in Tideways, this will look like this. So what can you see here? This is a screenshot of the profiler, and we are comparing 2 call graphs with each other. On the top, we see the base profile, which is for the controller that is exporting products. So what we did here in Tideways, we enabled the profiler for this controller to be activated for an hour and collect call graph information for that hour. And then we just waited a few times until Google sort of fetched the shopping data, and we got call graph information. And as Paul mentioned, the response of this was very low. It was 7 minutes to generate this output file, sometimes up to 10 minutes. And when we looked at the call graph, we found out that the Shopware used an inefficient data structure in core, which was fixed in version 6.4. And it was using a function called arrayUnique in PHP. It's a specific function that sort of optimizes or counts an array for a number of occurrences. The details are not very important. However, what is important is that this is not a bottleneck you would usually sort of guess. It is something that when you write this code, you would not be expecting it to be slow. So you find a problem in code that the author was probably not thinking of when writing it. You can only find out with real performance data that this is actually a problem. When we used the patch for Shopware 6.4 and sort of backported it to the Radonline shop, we saw a drop to 50 seconds of this request. You can see here that the arrayUnique function is called 31,000 times less. And by doing so, 4 seconds of the request, 4 minutes of the request were shaved off the response time. So this was sort of our approach of fixing this. We didn't upgrade to 6.4 yet, but we backported this one specific performance patch to the Radonline shop. One benefit of this caching API improvement is that it's not only making the export of products much faster in Shopware, but it's a general performance fix that will make every page faster, because the caching API is a very central API in Shopware. So you will see at least 20 milliseconds, but probably around 50 milliseconds reduction in every request, just due to this optimization. So after we did this optimization in the core, we looked at the different other scenarios that Paul mentioned. So we now optimized the product export. We now wanted to look at the product import and the time to first byte. So we went to optimize the time to first byte. We looked at all the different pages. So we generated profiles for the homepage, the category page, the product page, all the different pages, and looked at them and tried to find the reasons why they seemed sluggish compared to a Shopware demo shop that is sort of doesn't have products, doesn't have plugins, and everything else. So what we did is that we used the Tideways Profiler to look at all the different events that Shopware is triggering and where plugins can hook into. And we identified a few plugins that are slow and are causing the performance to drop in every request. Specifically, we found one plugin called Cookie Consent. It's a cookie consent plugin. I guess everybody has to deal with it. And there are a lot of plugins in the plugin store that deal with this. And we found an accidental use of an uncached translation API. So it's really not a mistake that that everyone can make. And specifically with Shopware 6 being so new, and everybody's still sort of learning how the performance is affected by Shopware. This is something that like a tiny mistake that everybody could make. And it's also, if you look at the code, something you wouldn't expect to be slow if you use it. So we talked to the plugin authors and suggested a very simple patch, and they happily accepted it and already released a new version. And that will shave around 30 to 60 milliseconds of every request, which brings, in the case of Radonline, was about 10% of the total performance. So it dropped the performance quite a lot. How does it look like? If we look at this in a profiler, so we have sort of, on the right, you can see the call graph, and it's not fully readable, but you can see at the top, the first node is the dispatch function of Symfony, which is the event system of Symfony. And it triggers an event called kernel response. And we immediately see that as a reaction to this event being triggered, there's a function in this plugin here, Acris cookie consent, which is quite slow, 40 milliseconds, which is something to look at. And we found the reason for this, as I told, was translations. We looked at the code. The translation at that point wasn't really necessary, so we dropped it. And then when we compared the performance again with our fix, we had 30 milliseconds one. Okay, so that is one thing we did for the time to first byte, reduce that by looking at sort of the events that are triggered. The performance improvement in Shopware Core that 6.4 will be causing is also improving the performance. But since Radonline hasn't upgraded yet, it's not benefiting from it yet. We will see how that works out once they upgrade. And the last point that we want to look at in performance is the product import. And we also found that it was caused by a plugin, but Paul will tell the story here of how he identified and improved this on their end.
Yes, as I said before, it took the RP 22 seconds to update the stock of one product.
Sorry.
That means handling the request, indexing the product, and answering to the RP. And together with our ERP system, we changed the request to the RP and added another HTTP header, which tells Shopware to use the queue indexing. By that, the indexing is moved to an asynchronous process in the background, and it now only takes 2 seconds per product to handle the RP request. Of course, this doesn't solve the problem, but it covers it. So as a temporary solution, it's okay, because now the stocks are updated properly again. And in order to update or index the products, you should deactivate the admin worker, which is activated by default. And then you have to run a cron that executes messenger consume, and this should speed up the indexing for the updating process. Yes.
Yeah, so by sort of pushing the messages into the queue, at least the ERP system could send the updates to the backend, because previously it took so long that the ERP system could run into timeouts and things. So it's not very, it sort of can lead to problems if you respond very slowly to third-party APIs calling you. And that this sort of delayed or moved the problem to the message queue that could now process the slow updates in the backend. So what we then did is analyze, why is it actually so slow? And this is also something where you, when looking at profiling data, you find problems that you wouldn't expect, or the plugin author sort of wrote code without expecting this to be a problem. And this is it's a very common problem, because a shop system and all the plugins, they need to handle so many different shops that they cannot account for all the different usage patterns. And this makes it very hard to develop a plugin in a way that is always performant. And you need to rely on the feedback of the users to give you feedback back that specific parts with specific usage patterns are slow. So this is actually sort of a symbiotic relationship between shop authors and plugin authors, shop owners and people running the shops and running Shopware, running plugins, and those writing them. But it's very important to give feedback back and suggest improvement ideas. So what we found here is that due to some accidental sort of complexity in the plugin, it used the data access layer in a way where the data access layer accessing functions were called 400 million times, which is quite a lot. And obviously leads to performance problems. If you look at the code, you wouldn't expect it to be slow. We looked at the call graph. We found out the problem essentially. So this is not, we found out that it sort of depends on this usage of the database access layer. There's this filter by property function, and this is very, very slow. And we looked at why this is happening, and found that the code actually doesn't really look like it's being slow. So the code is using an array of cached categories. So that is nice. We only make the query once. And then it tries to find the category with a specific ID from this collection of categories. And this is what triggers sort of this small slow code. And looking at this, you wouldn't expect it. But the problem here really is with the shop that it had a lot of categories, and this API iterates over the categories over and over again and checks each of them for the category ID, which in the end causes this performance problem. So an improvement would be to rewrite this to be accessible by the key of the category in the array. And this would lead to a large improvement. But only if you test this with sort of the setup that has tons of categories, you would actually see this performance problem. And it needs to be a combination of things. So you could have 1,000 categories and only, let's say, a few sales channels or one sales channel with one language, and you wouldn't see this problem. But by the combination of different things, there's an explosion of this API being called and leading to this performance problem. So we also talked to the plugin authors here and suggested this as a fix, but we haven't been able to test this ourselves in production to see how this improves it. But we also expect that this is making a very, very huge difference. So what did we learn from looking at Shopware Performance? So we learned that a lot of performance bottlenecks are unexpected code. We don't expect it to be a problem. We probably assume that the Shopware core authors and the plugin authors also don't expect it to be a performance problem. So it's always very important to look at your shop and identify the impact each plugin and each function of the core system has on the performance and how to optimize it. There's a question, isn't there a get key function in the entity collection that does that too? I don't know, maybe. I'm not sure if it's using the ID of the category as the key. Maybe it does, and then we can optimize it this way. I am not familiar enough with this, but maybe I can look at this, look at the API afterwards to see if that would solve it. Yeah. But again, this only proves the point that Shopware 6 is quite a new system. Everybody is scrambling to sort of port their plugins to Shopware 6 from Shopware 5 or other systems. And there's still a focus on features and getting everything working. And we as a development community still need to learn about the impact of individual APIs on performance, how to effectively use them. And that is something we need to learn together and help each other with to improve Shopware, improve the performance of plugins, and in the end, improve the performance of all the shops that are using Shopware. Okay, there's another question. Let me end the slide, then we can, I guess, do questions. So thank you very much for this talk. I wanted to end this with a small note of ourselves. We are currently looking for a developer advocate for Tideways, working on PHP performance, education and content. So if that's something you're interested in, check our page. If you want to contact me, you can send me an email. I forgot to add Paul's email here, I'm sorry. You can find him on the radonline.de website if you have questions to him. And yeah, if you have questions now, I guess we still have a few minutes to answer them. Let me look at the time.
We definitely do.
Okay.
We'll also have a breakout room as well for this talk. So if anyone wants to chat further to these guys, then they can at the end of all the talks as well.
Yeah.
Benjamin, would you like to take Christoph's question?
Yeah. So I will, I guess, answer the question that's in the chat. You told us that only a small percentage of Shopware pages is inside the HTTP cache. Did you check why this is such a small percentage and not more? Yeah, so the reason is that multiple reasons for this is that the cache gets cleared for various different reasons, and sort of like stock changes. So if you have a continuously running import, then changes in stock will invalidate the cache. And often plugins will accidentally invalidate the cache, and this is very hard to track. And then if you have a large shop, obviously the cache will only be active for, let's say, 5 to 10 minutes or something like this. The pages are really not visited that often, that they are always in the cache. So you might have a specific category that wasn't visited for an hour by any user. Then you have an uncached page. And this happens way more often with products, that a specific product wasn't looked at by somebody, and then the cache needs to be regenerated. So this is something that is just happening quite often because all the pages are not visited all the time.
Right, fantastic. Thank you. Any other questions before we move on to the next talk? Post them now or wait until the breakout? If not, then speaking very slowly, I will be thanking Benjamin and Paul for the talk. One thing I really liked what you said, Benjamin, was that it's a symbiosis between the plugin writers and the users of the plugins, and that you need to give feedback. And I think that that is something that a lot of people tend to forget. Right? It's easier to install a plugin, and if it doesn't perform, to just rant on Twitter. But at the end of the day, it's important to contact the plugin writer and to let them know, hey, in a friendly way, hey, I might have found an issue, maybe even offer them a patch. It's a collaborative effort, and it's good to point that out.
Yeah, and it's I think it's very so my experience is that it's always very good discussions and very sort of focused on getting the performance better and results. No plugin author is going to jump in your face and say, no, the performance is awesome. They are just really happy to get the feedback.
It works on my machine. Yeah, it's a good point. Thank you, Benjamin. Thank you, Paul, for the talk. And with that, we go to Thomas Lohner on the performance project. Thomas, are you ready to share your screen?
Yes, I am, of course. Thank you for having me. Let me quickly share my screen, and then we can start the presentation.
Perfect.
You see the screen, I guess, right? Or not yet?
Nope.
Not yet.
Not yet.
Okay, sorry. Also, I have to click confirm, obviously. Now?
There we go. Yes, thank you.
Perfect, thanks. Okay, so this talk is called the Performance Project, and the project here is on purpose because optimizing performance is not a one-time job, but instead you have to do this continuously, and I will get back to this matter in a few minutes. The first thing you all need to know about optimizing performance is that in fact it is very, very easy because the internet is full of tips and tricks and techniques about how to make your website faster. The only problem is you need to know which of these tips and tricks do apply to your website and which don't. So it's not about it's too complicated to do. The more obvious problem here is what should I do? So the goal of this talk here is I want to show you how you can sort of create a very simple to-do list with all of the steps that you need to do for your particular shop so that it is better than before. But before we do that, let's take a step back and talk about the two different approaches that we can use to optimizing performance. The first approach is we can add more horsepower. So obviously this will work by adding more power to what we already have. We can increase the performance. Everyone knows that. And this will work quite well, but this will also be a very expensive approach. So if budget is not the problem, then this is the way to go. The other approach would be to make it light and fast. And this here may seem very, very obvious, but the problem is that in reality, this is so hard to do because every one of you guys who has ever done a relaunch of an online shop or has participated on a relaunch most likely has seen something like this. And the problem here is that we tend to add stuff to our online shops on a regular basis. I rarely see online shops that get developed, put online, and then no changes are made. The most common, more common case is that on more or less a daily basis, someone is working on the shop and someone is adding like stuff and adding features. And it's a bit like a backpack. So the more we put in, the more heavier it gets and the more power we need if we want to run with the backpack on. So what we really need to think about here is, do I really need all of this? So I would really love to see online shops start measuring how many of their customers are really using the features that were added. And if a feature is not used or does not contribute to more sales, then why can't we remove this? The reality here is that we are very, very quick in adding new stuff, but we rarely delete or remove stuff. And this is also one of the topics that Paul and Benjamin touched in their talk. When you add plugins and then this plugin introduces a performance bottleneck, then maybe you can fix the plugin, but also you can have another look at if you really need this feature. So let's for now define performance as page load time. And let's have a look about the two different parts of an online shop where we have page load time. The first one is the application itself. This is what we call time to first byte. And basically, this is what Benjamin and Paul covered in their talk. So from a user perspective, this is the time, how long the browser window is empty, because the application in the background, the application on the server is working. And when the application is done after the time to first byte, what happens then is that the browser is rendering the shop. This is where Google Core Web Vitals come into play. And I will get back to why this is important in a minute. So what we did now is we wanted to see what is the impact of the application and what is the impact of the rendering in the browser on the total page load time, on the total performance of the shop. So what I did is I just chose some random shops. It absolutely doesn't matter which shops these are. What you see here is the page load time in dark blue, that's the application, and then in green, that's the rendering in the browser. And what we can see here basically is two things. First of all, obviously, the application time is crucial because this is the time that the user does not get any feedback or any interaction. This is where the browser window is literally empty because the application is working. So the longer the application takes means the later in the timeline the browser can start showing stuff. This is one thing that we see here from this analysis. But the other thing that we also see is that in terms of impact on the total performance, everything that happens in the browser, everything that happens after the application has a much bigger impact. So what does it mean? Maybe some of you will not like to hear this, but in my opinion, this means that it honestly does not really matter which software to use as an application, because most likely the bottlenecks that you will find in your particular shop will not be in the application, but it will be in the front end. So this means that choosing which software you want to use for your online shop will have lesser impact on the performance than what you do with your online shop in the future. So everything you add will sort of bloat the system and will sort of add render time. So let me give you some examples of this. Many of you may know this sort of picture, which you can do, what you were able to do with Shopware 5. So basically, what happened here is that the HTML framework, let's say, is rendered super fast. So the application time to first byte is super fast, But from a user perspective, the experience is quite different, because for me as a user, this site is empty. It's not an online shop. I cannot do anything. And what happened here is that we tried to load the main content via Ajax. So this was sort of cheating performance, because from a measuring of time to first byte perspective, the shop was really fast, but from a user experience perspective, it was not very fast. And this is one of the reasons why also Google is switching from keeping measurements with a stopwatch to user experience. So what now with the Google Core Web Vitals is more important than the actual time to first byte is everything that happens in the browser and is the user experience. Let me give you one more example of what I mean here. So not sure who of you knows these chatbots. I personally really hate them because I don't like to use them, and I'm annoyed when I have to click them away. But I totally get that this is a feature that can add a benefit to an online shop. The problem that I see here is that I would love shops to start counting how many of their users are actually using this feature. So I'm not sure how many this is, but if I would guess, I would say maybe something between 1% and 5% of the users using this chat box here. And the problem with this is, oh no, let me explain it the other way around. There's absolutely no problem in adding a feature to your online shop which only benefits 1 or 5% of the users. But what is absolutely a problem is to punish 95% of your users with loading a feature that they don't want to use. So what do I mean by that? What I mean is, if you want to add, for example, a chat box, what you could do is you can just add a fake button like a static HTML or a static icon or whatever. And then if the user clicks on that and wants to interact with the chat, then on that click, you can load the application. While doing performance profilings, we have literally seen frameworks of live chats which added 6 more JavaScripts to the shop. And it's totally okay to add this if the user wants that, but it's absolutely not okay to punish all the other users with loading stuff that they don't want to use. So another example would be adding or including YouTube videos in the shop. So what you can do here is, instead of loading the YouTube JavaScript, you can also just put a fake screenshot with the play button on the site, just a static image. And then when the user clicks, then we can load the YouTube JavaScript, the play, and then we can play the video. Because users will expect that when they click on the play button, that it will take like half a second or so until the video actually starts playing. Users will not expect that the video just snaps like on click. And with this trick, you can save all the users that do not want to watch the video with some time in browser rendering, which we have seen is the bigger part of the overall page load time. So how do we fix this? This is very easy. We simply need to monitor all of the key metrics. But this brings another problem, because monitoring the key metrics is not enough. What we also need to do is, each of these metrics we need to evaluate, and we need to figure out what can we do to make it better. So if you, for example, measure the performance of your shop, and any metric you get the value, let's say 1.0, then the first problem is, how do I know if 1.0 is a good or a bad value? And the second problem is, what do I need to do to improve this value. So what we see in the real world is we have lots of metrics that we need to monitor on the one side, and then on the other side we have lots of rules which we need to evaluate each of the metrics to be able to get some real to-dos. What do I need to do with the online shop? And this can be a bit overwhelming. And in e-commerce, we can add even another dimension to this problem, because in e-commerce, we have different page types with different features, with different layouts, and with different performance use cases. So what we really need to do here is we need to check all of the metrics that are relevant, for example, for Google Core Web Vitals, and we need to check them against each of the page types that we have. And then also we need to check them against each of the devices, because we have desktop and also we have mobile. So now we already have like 8 pages, and on each of them we need to check a bunch of metrics. So if we do this, for example, with tools like Google Lighthouse, then we are this is quite okay. But the problem here will be that this is what we call synthetic tests. So this means I can test how fast or how slow is this particular page in a lab environment by just loading the page and sitting there with a stopwatch and try to measure all the results. But this will not be the same as the page load time for all of your users. This is what we call real user monitoring. And this is because your users will have different kinds of internet connections, different kinds of Wi-Fi, different family members who maybe use up all the bandwidth or maybe not, and also different devices. So what we really need to find out is how fast is this online shop for the users that are trying to buy products here. So quick summary here is we have a bunch of metrics times 4 page types times 2 devices and times 2 methods, the synthetic tests and the real user monitoring. And this can be quite overwhelming. So the solution for this is a tool that we have built, which is absolutely non-commercial, free to use. We built the tool because we needed this to be able to analyze the shops of our customers. So this is commercescore.io, and let me quickly go through what this is and how this can help you to create a simple to-do list of actual tasks that you can do to improve the performance of your online shop. So how does it look like? Basically, under the hood, what we do is we use the same tools that also Google uses, for example, Google Lighthouse and some other tools, and we run an analysis on your shop on every page type. So this is the result. And let me show 2 things here. And by the way, sorry, I apologize for the German screenshots. Commerce Score is also available in English, but I already had these and I was a bit lazy to create new ones. So what we see here is just a list of, it's just a list of the metrics that we measured with Google Lighthouse. And then we see the result in the middle column, and then the right column is where the magic happens. So what we did here is that for each of the metrics, we tried to come up with a scoring rule. So first of all, with the scoring rule, we can help you identify if the value, the measurement of your shop in this particular metric is a good or a bad number. So if it's good, then it's green, and if it's bad, then it's red. And the other thing that we were able to do with the scoring rules here is that we were able to help you prioritize which of the metrics are very important to fix and which of the metrics are maybe nice to have. And this we have achieved by assigning a particular score to each of the metrics. The scoring rule is transparent, so you can just mouse over the I for information icon, and then you will see the yeah, if you're green blind, I'm really sorry. Then we messed up. Just saw that in the comments. Maybe we have to find another way for this. So basically what happens here is that if you analyze your shop, then the result will be that you really get a simple to-do list. You start by fixing everything that is red. And if you then have some energy and some budget left, then you go ahead and fix everything that is yellow. And if you're done with that and everything is green, then your shop will have improved in performance overall, regardless if the improvement was in the application, in time to first byte, or the improvement was in the front end. So the score that you see here in the upper left, 530, is the combined score of the home page for this particular shop. The maximum score is 1000. So you can see here that this shop is not bad, it's quite good, but there's still some potential. And let me just explain two things here. So the metric total byte weight measures how much data needed to be sent to the browser. Here, this is 15 megabytes, which is absolutely too much. And this value is so bad that we did not give any score to this, but we also punish this with a -25 score. So why is this important? Especially for mobile devices where the bandwidth is not as good as for desktop devices. Every byte that needs to be transferred to the client takes time. So the less you transfer, the faster the client can render the page. And the second metric I want to emphasize here in this particular example is the number of JavaScripts. Here we can see 22. This is also a big problem because the difference between desktop and mobile devices is not only the size of the screen, but in fact, it's also the capability and the performance of the hardware. So mobile devices are slower than desktop devices in terms of the CPU power. And this means that the more JavaScript I do in the website, maybe on a desktop client, it will still be fast enough, but on a mobile client, because the mobile client is slower, has slower hardware, doing lots of JavaScript can mess up the performance. Another thing that we see here, and I know I promised to only talk about two, but one more example is the number of web fonts. So what we see here is this shop has included 8 fonts, and we punished this with a -25 score. Why is this important? Including web fonts is, in my opinion, a lose-lose situation, because either the rendering of in the browser needs to be stopped and is blocking, because obviously the browser only knows how to display the text when the font is already loaded. You cannot display the text when the font is not loaded. So actually, you can tell the browser to start showing the text before loading the font. But what then happens is that sometime in the middle, it will just switch, right? So the page starts loading with a default font, and then in the middle it will switch to a different font. And this, from a user perspective, is also a bad experience. So from user perspective, we either have to wait until the font is loaded, or we get irritated by the website or by the page sort of jumping around. And this is also, this jumping around of the website is also one of the key factors that Google Core Web Vitals will punish if you do this. And also, but this is just my very, very personal opinion, I have until now not seen a single online shop who could show me how much more products they sell because the font on the page is the same as on the business card. But on the other hand, I found a lot of online shops who showed me how much more they can sell when the page loads faster. So this is for everyone to decide if you want to do this or not. And this is also why we have built commercescore.io, because this analysis helps you to not only to analyze the measurements of your shop, but also to evaluate what is important and what is not important. And the result here is really a simple to-do list. You start by fixing everything that is red or has a minus. Okay, so everything I told you until now is what we call synthetic testing. So this is running a Google Lighthouse against the homepage. But what we also need is the real user monitoring. So not only how fast or how slow is the homepage for a browser and a lab environment, but also for the real users. And luckily, Google has an API that exposes real user experience. I'm not 100% sure where this data is coming from, but I think some of the data comes from anonymized Google Chrome users, and some of the data also is coming from Google Analytics. So the Google Core Web Vitals test here is the real user monitoring from what Google has seen from real users. So basically here we see both. We see the synthetic testing and we also see the real user experience. And by the way, I can later share the URL of this shop. But for now, let me just continue with the slides. So, and yes, it's Ernst Ding's family, it's right. In the chat, someone already posted the URL. So what we see here is the analysis for homepage on a desktop device. And then we do the same for the mobile device, and also what we store. And by the way, what we see here is this we see on a lot of online shops when we do performance profilings. Everyone talks about mobile first, but in reality, this is simply not true. Nearly all of the performance profilings that we do will show that mobile performance will be much slower than desktop performance. And this is not because the template is changing. This is because of how much data needs to be transferred and how much JavaScript is being done on the mobile device, because the mobile device is slower than a desktop device. Additionally to what you see here, we are also storing the original Google Lighthouse report with all of the details that you see there. So you can also, for every measurement of every page type in either mobile or desktop, check out the Google Lighthouse report and go through all the information that you see there. Also, what you can do is you can create an account, which is for free, and then you can have your shop tested on a regular basis. Let's say, for example, every day. And then you can have a history of your performance per day. So this is very useful if you want to do changes, and then you can check if the changes are improving the performance or not. So until now, we have covered the part which of the metrics are important and what they really mean, and how do I come from a metric value to what do I really need to do with the online shop. What's missing until now is what would be the goal of a single metric to achieve to be one of the top online stores. So we also have this on the site. So for each of the devices and each of the metrics that we check, and let's, for example, take the number of JavaScripts here. The top 20% of the shops will have 8 or less than 8 JavaScripts. And with top 20%, what I mean is the 20% with the highest overall score, not the top 20% regarding the metric of JavaScript, but the top 20% with the highest score. So the lowest 20% will have 39 or even more JavaScripts added to their page. So this is very useful if you honestly are not sure if your shop needs improvement or not. So it's not always very intuitively visible if this is fast or slow, or if it is fast enough. So with this, you can just compare yourself to the top or to the lowest 20%, and then you can decide for yourself for each of these metrics what your goal for your particular shop could be. So what's the conclusion until now? The conclusion is that which software in the back end you use as an application for your online shop will not make such a big difference as what you then do with your online shop, what you add on a daily basis. And this, only this will make the difference between being almost perfect and having a lot of potential for improvement. And the problem with this is that it does not happen overnight, but it slightly is happening very, very sneaky. So you add this little feature today and another really small feature tomorrow. And then after 6 months, you see that the performance impact may be really bad. So what I want to advertise is that you need to keep the features of your online shop and the performance in some sort of balance. And you need to know that everything you add to your shop is going to be paid from your performance budget. And this is not what we want. We don't want to overspend the performance budget, because what we in the end want is our online shop to be irresistible for the customers, so that the customer buys the product on our online shop. So if there's only one single thought that I could wish for you guys to take out, to take away from this talk here, then it would be to ask yourself if you really need all of this to sell the products, or if there is anything you can remove from the shop, because this will be the most cost effective and also the easiest way to get rid of stuff and to improve the performance. So this is all I have to show for the tool Commerce Core IO. I was not quite sure in terms of how much time we have, so I have prepared some bonus slides about the topic on how do you know until which point you should improve the performance and how much more money you can make with this. So Sander, I'm not sure if should I spend like another 6 minutes or so, or should we go to questions?
We are running a bit over time, so I'll make you a deal. You'll get a breakout room after the last talk. And I think a lot of people actually want to join you there, also for the link to the score page.
Okay, so
Sorry,
this is
that's a joke, Malte.
so this is exactly why I also included the thank you slide here just before the bonus slide start. Okay, so that's it. Thank you. Please add me on Facebook if you have any further questions. Either we can talk about them now or later in the breakout session with some bonus slides about how you can see how much more money you can make if the site would load faster. Thank you.
Thank you, Thomas. Any quick questions for Thomas before we move on?
I would have 2 questions.
Sure.
The first question is, what do you think? Before you spoke always about to remove stuff of the online shop to make it faster.
Yeah.
But my question is, what do you think about Google's approach of accelerated mobile pages? And why do you think such systems like Shopware don't use it for their online shops?
Okay, so you're touching the PWA area here, right?
No, the AMP, accelerated mobile pages, is not PWA. It's a different approach.
Okay, sorry. So first of all, let me answer the second part of your question. Why is Shopware or any other vendor doing it like the way like they do? And basically, this is something that also Benjamin and Paul have talked about in their talk. As a vendor, you need to be as compatible as possible to every use case that is out there. So what you try to do is you try to use the smallest possible solution that fits for everyone, and then you need to be flexible with how people can use it. So and this will never be the best solution, right? This will always be a solution that is okay for everyone, but it will never be the best solution if you want to stay compatible with every use case that is out there. And how do vendors fix this? So Shopware 6, for example, tries to fix this with the approach that you can use it headless. So if you don't want the standard front end, if this is not good enough for you, or let me explain the other way around, if this is good enough for you, here you go, just use it. But if you want more, then you can use the API. I think it's the storefront API in Shopware 6, and you can build your completely own front end and use Shopware only as an API for the product data. Does this a bit answer your question?
Yes, the second part and the first part, what do you think about this approach of the accelerated mobile pages?
Honestly, I'm not sure. And let me explain to you why. I think there's a huge difference between trying to optimize for performance and trying to have an online shop that is easy to use and looks beautiful and sells products. And honestly, I am not sure what the best approach is to achieve the goal of the online shop. And the goal is not to have an AMP. The goal is not to use Shopware. The goal is to make money and to sell the t-shirts, right? So I'm not sure if maybe Erwin can touch on this topic a bit more, but I think it's more in his expertise. So looking forward to passing this question on.
Okay.
That's a perfect segue, Thomas.
A short second question, when we have time.
For the sake of time, would you mind taking that to the breakout after Erwin?
Yeah, sure.
All right, thank you so much. Just on the AMP, I posted a link in the chat that touched on the AMP, and it seems that Google is kind of dropping AMP as well, so that might be relevant to your first question. We're quickly moving on. Thank you so much, Thomas, for your presentation. I definitely liked your quote that saying webshop is like a backpack, and the more you add, the heavier it gets. That is something that every merchant should hear loudly. Last up is Erwin Hofman. Erwin specializes in core web vitals. If you didn't know this by now, that is a very important topic for performance. And Erwin is going to take a deep dive into that with his talk, Shopware 6 as your ideal core web vitals boilerplate, ? Erwin, take it away.
Thank you, Sander. Yeah, let me first elaborate on the accelerated mobile pages question. Obviously, accelerated mobile pages has a lot of bonus points towards performance. As a matter of fact, all those bonus points, all those best practices can be implemented in, well, maybe not any shop, but could even be implemented in Shopware. So if you're really considering doing AMP, accelerated mobile pages, well, Sander already posted the link in the chat. Don't do it, because you're basically building yet another front end, and you end up maintaining maybe two versions, because often AMP is just like a lightweight version of your regular page, but you're limited to a certain amount of CSS, but also a certain amount of JavaScript. So you always have a very lean page, which is maybe good for user experience and perceived performance. But I would then advise to put those efforts into your own shop, optimizing your very own shop. And yeah, it could be a bridge to my talk in such a way that Shopware 6 already is quite a good boilerplate. For example, if you compare it with Magento 2, Magento 2 has quite a bit of JavaScript going on, which is really impacting performance, like Thomas was already explaining as well. And it isn't just JavaScript, which is the bottleneck, but it's also how you use JavaScript. For example, Magento is already loading often they're already loading JavaScript first things first. So it's really render blocking, but also parse blocking. So it keeps the browser from doing what it should be doing. What Shopware is doing is it's basically deferring all JavaScript because it's moved to the footer. So if you move JavaScript to the footer, it's the same, it's the equivalent of deferring JavaScript. There's a little nuance, but not important for today. So this basically means Shopware is already enabling the browser to do its work as fast as possible without really pausing it. And sure, CSS is still render blocking. And you could implement strategies and best practices like AMP is doing as well, etc. Accelerated mobile pages is using critical CSS. However, critical CSS implementing critical CSS can be quite tricky and also come with layout shift challenges, for example. So I would say put critical CSS at the end of your to-do list. All right, I'm going to start sharing my screen. Because, well, any green score in LinkedIn or whatever platform might always be doing good, like this one over here as well, my very own post, 98% score. However, this score doesn't matter at all. And the reason is exactly, well, what Thomas was already explaining as well. It doesn't matter because it's lab data, it's syntactic testing. A lab data test in, for example, Lighthouse or PageSpeed Insights might be done on certain circumstances. And it doesn't tell the whole story about real user experience, the so-called field data. And to answer another question, well, not really a question, but all this data is only coming from the so-called Chrome user experience report. It's not coming from Google Analytics. It's only coming from one database, and all Chrome devices are basically, without knowing, basically submitting all their experiences and metrics to the so-called Chrome user experience report. So one takeaway might already be this overall score, 98%, even on mobile. Yeah, it's a good score. It will always work on LinkedIn to get some engagement, but it doesn't matter. And the subject I was talking about in this very specific post is when you would enlarge your image, you get a better score, which might sound a bit weird, but this is exactly how Core Web Vitals is working. the so-called largest control paint might often be the hero image or product, if the product image, for example. And it looks at when the largest image is done loading, or the largest text node is done loading, like a heading, for example. And we enlarged the image to, well, span the whole width and height, the full viewport dimensions, you could say. And this is how Core Web Vitals is working. When an image is full width and full height, then Core Web Vitals, or you could say Google, is considering it as a decorative image instead of a meaningful image. So it won't see such image as a largest control paint. So that's why we got a high score over here. So if you've got any homepage, for example, with already a very big image, then try to make it a full viewport image instead, and you get a better LCP for free. All right, that being said, I won't dive into each Core Web Vital metric today, but I will dive in a use case in a shop I used and audited also in preparation for this talk, but also to enable them to speed up. And this basically is, you could say, complementary to earlier talks. For example, to start with, time to first byte. And we did some real user monitoring over here as well, because, well, Core Web Vitals is once again about your real audience, meaning if your audience is within Europe, for example, or the Netherlands, I guess internet connectivity in German isn't as good as in the Netherlands, but we're a smaller country, so it might be a bit easier to get everyone a good internet speed. But the time to first byte, I audited this website using real user monitoring because the Core Web Vitals of Google themselves didn't have sufficient data for all different pages. And also the field data of Core Web Vitals isn't from day to day. So you can't see any changes, for example, in improvements in your scores. You have to wait 28 days before seeing any results. And it's a bit, well, especially when you're doing multiple releases in a week, or maybe one release in a week, you don't know if it improved or decreased performance, for example, if it improved user experience or not. Time to first byte is one of the first metrics I like to look at when auditing a web shop. And what I see over here, what I saw happening is at the 75th percentile, the overall experience was, well, more than 800 milliseconds. And the biggest bottleneck was when users tend to visit the page using, well, yeah, advertisement links. So when they would click on a Facebook ad, for example, or Google ads, or even any campaign parameters in the URL. So what you see over here, the 456 milliseconds is caused by users visiting the web shop without any query strings, without any parameters in the URL. And it resulted in a good time to first byte at the 75th percentile, once again, with a total 65% having a good time to first byte being below 300 milliseconds. And users having a query string in the URL, so visiting a page with a query string, ended up having a time to first byte of 3 seconds at the 75th percentile. So we can see over here that about 68% had an experience of more than 1 second. So this already is a quick fix in such a way that you then just have to configure your CDN, for example, in this case, a Bunny CDN, but you can do it for any CDN, obviously, to configure it in such a way to ignore those query strings when they, well, basically aren't changing any contents. So, and yeah, the average Google ad, for example, or the average Facebook ad or campaign won't change any contents on the page. So you can just serve an already cached page. All right, and this is also a takeaway when it comes to Core Web Vitals, because Core Web Vitals is tracking all page views. It's not only tracking the first page view, so it won't only track uncached pages, but also successive page views, for example, or when a user is coming back to the shop the following day. And you can clearly see a change, a difference within visitors visiting a shop for the first time, without any resources cached, like CSS, JavaScript images, but also, for example, successive page views. So the second page hit, the third page hit, etc., where both resources, but also the DNS lookup will be cached in the browser, for example. And well, yeah, the difference is quite obvious. And the returning visitors are users who are likely to have some resources cached, but then will return maybe, well, the following day, and a new DNS lookup has to be done. So once again, it isn't about lab data, because lab data will only track fresh page load with all resources, well, all uncached resources. But the average experience obviously also is about, well, successive page views. You also want to have your visitors to have an optimal experience on, well, when they go to the cart, or when they go from a listing page to a product page. This also isn't something that Core Web Vitals will tell you. You aren't able to see what really impacted your maybe negative Core Web Vitals score. So this website, this is the web shop, I should say, this is the LCP. This website is likely to overall to pass Core Web Vitals, but if you would only take into account the unique page views, for example, it wouldn't be passing Core Web Vitals, and it might make you blind for, well, yeah, the first time page view experiences. So once again, Core Web Vitals is quite handy. It's actually quite transparent as well. It's already giving us some goals, some clear goals, not only for your SEO ranking, for example, but also for your bounce rate, because yeah, those metrics weren't taken out of the blue. Google came up with a certain set of metrics, currently free metrics, because they found out that when you would meet the thresholds of those free metrics, the chance of a bounce, the chance of page abandonment would decrease by 24%. So you would benefit SEO wise, but also conversion and bounce wise. This is the page load metric. And yeah, this is the page load metric. And once again, like Thomas was explaining as well, the amount of resources does matter towards certain metrics. In this case, we can clearly see that, well, this is not the internet speed, this is the device memory. So this basically means how much your device can handle, can process. And we can see a clear difference in, for example, a 2 MB device memory, or more than 2 MB, yeah, 2 gigabytes memory, or 8 gigabytes memory, that there is quite a difference within the experience the user will have, depending on their yeah, circumstances. And I also have an option to, for example, set it to the bandwidth, the internet speed. And what I found out is from 4 MB internet speed doesn't have a correlation towards user experience. So obviously the average website will be about, well, around maybe 2 MBs or maybe 4 MBs, somewhere in between. And as of 4 MB, the internet speed doesn't have a real correlation towards, well, the UX metrics, the user experience metrics. And it's basically proving that there are different metrics in play. You have to take into account different factors. It's not only about internet speed, but also about user and device circumstances. This isn't QuickParts anymore. The QuickParts DK webshop, which I audited. I will come back to that later. But we can also see a clear difference within different devices. Desktop will often perform better than the mobile device. Once again, this is the 75th percentile, and tablet devices tend to perform even worse than both mobile and desktop. And this is the internet speed I wanted to point out, is it? Yeah, this is the bandwidth. And I hope I'm able to tell the same story over here, that we can see at 1 Mbps, there is an experience around 3 seconds for the largest control pane. So that will be the main image, product image or hero image. And as of 4 as of 4 Mbps, we don't see a clear correlation. Like 5 Mbps has a better experience than a worse experience at 6 Mbps, and 5 Mbps even has a better experience than 7 Mbps or 8. And we do see that anyone above faster than 10 Mbps internet speed has a better internet connection, but it can also be like 50 Mbps. So they will always have a better experience than someone with 8 Mbps. But we also see that the correlation here is no longer there. And this is once again, well, this is a Dutch web shop, and we can even see data per page type. But also this depends on is someone using a mobile device? Is this the first page hit? What kind of memory does the device have, etc. So they're all different kinds of circumstances we have to be aware of. It's not only server side, but also front-end side, client side, which matters today. Going back to the web shop which I audited, this is the quickparts.dk. And next to doing some real user monitoring, I also dived into a web page test. And if you haven't read my article yet, then I'll just be diving into some quick wins. And one of them is Google Fonts. Google Fonts is all okay to use in such a way that often it won't be the biggest win towards Core Web Vitals, for example, also because their servers tend to be quite fast. However, it might impact the first visit because, as we can see over here, we see some colored bars, which is the DNS lookup TCP handshake, for example. And obviously, it has to be done the first time. So it might slow down the first page experience a bit more than, for example, successive page views. Moreover, we see in this specific test, tested from Amsterdam on a Motorola device, we see that the first control paint happens at 2.8 seconds. It's all blank at 2.7 seconds, and at 2.8 seconds, we almost see the whole screen at once, which means there is a very big random blocking issue going on over here. And this was quite an interesting find, although not rocket science, but this is the style sheet. And this used to be a very good, well, I'm not sure if it's a very good practice, but this used to be a good practice, importing another style sheet in your very own style sheet. And I also see this happening, for example, on Laravel shops or Laravel sites. And when you use add import in your CSS style sheet, the add import fetch will only be done, executed once the whole style sheet was downloaded, obviously, because the browser won't know what's in the style sheet until it's fully downloaded. So the browser will download the whole style sheet, and only when the whole style sheet was done downloading, it's able to, well, tell or see which other files should be imported. And this is basically resulting in a chained reaction, you could say. It's basically resulting in a chained delay, because that's what we can see over here quite clearly. I've got a red vertical bar. Let's enlarge my screen a little bit. And we can see that at request number 2, at my red bar, the download of my primary CSS was done downloading. And that's exactly the moment where another style sheet started downloading. So we can basically draw the conclusion that we introduced a bottleneck of more than 700 milliseconds, which is easy to fix by not putting such Google font in our own style sheet using add import, but by using a regular link element in a primary HTML payload, for example. That was already one of the takeaways. I've got them over here in my article as well, if anyone wants to read them. And also your HTML size does matter, because the browser has to do a lot of work to render all those elements which are in your main document, and it won't impact. It isn't likely to impact, for example, your first control paint, because a browser will render elements as HTML is being streamed into the browser. However, if you've got a very large HTML page, then the browser has to do a lot of painting work, for example. And that can actually impact the overall performance and might even block the main thread of a browser. And yeah, browsers are single-threaded. There is some nuance to it, but browsers are single-threaded, meaning if you are doing a certain task, or if the browser is doing a certain task, no other tasks can be done on the same moment. And I've got an example of such situation, which might be a bit more illustrating. And it should be over here. So I've got two squares over here. And when a chat widget, like Thomas was talking about as well, or your very own first-party JavaScript, for example, if it's doing a lot of work on the main thread and blocking the main thread for a certain amount of time, no other tasks can be done. And that's what I'll be demonstrating here. So I'm going to deliberately block the main thread for 2 seconds, and I can still click the checkbox, but when I click the 2-second button, I'm not able to click the checkbox anymore. So once again, I'm not able to click the checkbox anymore. And browsers already try to do a good job themselves, because I can once again freeze my browser, but I can still do some scrolling, because browsers already thought, okay, if developers don't do their work, then we should also optimize at the same time and meet them in the middle. So any scrolling behavior is being offloaded to another thread within the browser. So that, well, once again, when there are some heavy JavaScript tasks going on in the browser, a user can still scroll, or a user can still zoom, for example. It's a little bit of a different topic, but the reason why the green square is still moving is because I am using hardware acceleration. It might sound like rocket science, but it's just run one line of CSS. Which I might show later on, or, well, let's do it directly. So I'm using GPU, the graphical card. I'm using, well, I'm basically offloading the animation of the green square to the graphical card, and you can clearly see the difference. The whole element is moving along with the selection. And I'm using transform, and I'm then using transform translate to move the green square from left to right, while for the red square, I'm using margin to animate the element. And when you use margin, or maybe top, height, or bottom, or left as a, or even padding, if you animate such CSS properties, it will also, block the main thread. So if you do, if you've got some JavaScript going on, you might get a laggy behavior. You might get laggy animations. So using one line of CSS being transformed, we can offload such animation to another thread, to the graphical card. And as a result, it will keep moving. The animation will keep happening while the main thread was blocked, for example. All right. What I see happening in most shops is a lot of images loading at the same time. And what I saw over here within the Quick Parts web shop, which I audited, is the first image is the main image, which was on the top of a product listing page. And in this case, a main image on the homepage itself was downloaded quite soon. However, at the same time, it is competing with other images as well. So this is why lazy loading, and we can already do lazy loading natively, meaning we don't need any additional JavaScript anymore for most browsers, by the way. It's kind of progressive enhancement, you could say. So for example, Firefox, but also Chromium-based browsers like Opera, Edge, and Google Chrome itself is already supporting native lazy loading. And it shouldn't take a lot of time to implement it. And it does come with a win in such a way that resources won't compete with each other anymore. So it's already quite a good performance win out of the box. Well, a topic we already know, like cookie notices, but also third parties, will be impacting your overall experience, or could be impacting overall experience. Third parties aren't really likely to impact your core web vitals, because a chat widget, for example, A chat widget is just sitting still in the left bottom or right bottom of the window, and it isn't pushing any contents down. It also isn't the largest element on the page, so it isn't likely to impact your core web vitals. However, obviously, there is always it depends. It also depends on how it is implemented. And that was also something I saw over here, for example, a chat widget or a site search. Those were both loaded directly into the within the initial HTML payload. And as a result, they will compete with other resources. For example, they could push back your, well, maybe even your product image, which is responsible for your LCP. So as a result, those third parties which are loaded with a too high of a priority could impact your core web vitals. A better strategy is to, well, especially for your crisp chat, for example, to load it using Google Tag Manager. Don't use the page load, the page view trigger, but use the window loaded trigger in Google Tag Manager for third parties, which aren't important at all for user experience or for tracking purposes, for example. And yeah, basically what Thomas was explaining as well, and not all users will interact with a chat widget, and not all users will start searching the site search right away from the first second when entering a page. So that's another reason to give such resources a lower priority. You might even wonder if a chat widget should be behind a cookie notice, which is something I could demonstrate well when throwing away all my cookies. All right, should be good to go by now. And on mobile devices, so let's refresh the page. And then I should be able to tell what the largest element on the page is. Luckily, it's not the cookie notice, but on some pages, if you've got a page without any images or other large elements above the fold, and I think they already used less text in the cookie notice. I think when auditing, the cookie notice was a bit bigger, but we could try and search for another page. So I'm currently opening up another screen to go to a page with less text. Well, this might be a bit too big. Maybe a listing page. Yeah, this could work, not sure. So in this case, yeah, the cookie notice is still a bottleneck on certain pages, which is also proving Core Web Vitals really is template based. You could say it might be different per template, per page type. So if you've got a product page, it's quite likely that your product image will be the biggest element because, well, it's an element above the fold, which is covering most pixels in your screen. So in this case, the cookie notice is shown later on. It's shown later than the heading, for example. And it's basically now impacting your LCP metric because first-time visitors aren't likely to, I guess, didn't accept cookies yet. So they will first see the cookie notice, but maybe only after a certain amount of seconds. It loaded within 600 milliseconds over here, but I'm obviously testing on a desktop instead of a mobile device. Although I did set this to a mobile device, I am not really simulating a real mobile device. So your page type, your type of visitors are all circumstances you have to be aware of when addressing Core Web Vitals. I think this is also a good end of my talk. So I guess let's go to questions.
Right, I'm just looking through the chat. For anyone interested in more details, Wouter was so kind to post a link to Erwin's blog post in the chat. So scroll up a little bit. Any questions for Erwin?
Why don't we put them in the breakout rooms?
Perfect. In that case, dear people, we're gonna go to the breakout rooms. Justin, I believe Zoom now allows people to pick their own breakout room, right?
It does. You should
So
see the
let's hope
opportunity.
Right. Let's hope
Yeah,
everybody updated their Zoom. Otherwise, you're stuck in the main room.
I've created 3 breakout rooms. If the speakers could go into their respective breakout rooms, that'd be great.
Right. Perfect.
I'm not sure
So
if it
if-
already works for every attendee because for me, it's the breakout rooms are not showing it. I think you have to allow people to go in there, right?
I do.
Can you open them? Just
I can assign you, Thomas, into one.
Can you assign
I've
me
opened them
too?
all.
Yeah, assign me too, please.
Erwin, I'm going to put you in your room.
Awesome.
go to your room.
Get into your room.
Yeah.
Does
No
anyone
dinner.
see? Does anyone? And do people see these breakout rooms? Does anyone see them?
I don't see them yet. So I think you
Not
might
yet.
need to open them.
What have I done? I think I've opened them.
You may also need to allow for the attendees to switch rooms.
Oh, now we're getting technical. No, I think I did that already. Breakout rooms. Come on. We've done this before. It worked so well last time.
Do you want to continue the recording, by the way, or?
Yeah, I think we might stop that as well.